Even look into the night sky. You see stars way away. You see galaxies very far away. When you do thus looking up out there, that's how long it takes light to reach the Earth. You're looking backwards in time. The time it takes light to reach Earth is how away the star is. So, why does time stop at light speed? Is the big question. Light has a limit, a speed limit. Alpha waves forwards, beta waves backward. Alpha waves cancel out beta while VSO light stays at its limit. The speed of light. If you travel to that star 5 light years away, it'll take you 5 light years to get there. But from Earth, you're looking at that star 5 light years away. Light takes 5 light years to reach Earth. A ship crew wanting to travel to that star 5 light years away will be traveling backwards through time to get there. The star's 5 light years away. Why does light take that long to get to us? Traveling backwards in time, it's space that creates the corridor for travel. Our crew starts outreaches light speed where time stops. But is it that time stops describe what's really happening? The answer, no. It's not time or light that dictates how far away our star is its space. You see, space is made up of layers. Like a particle accelerates can measure what particles can be observed by how many nanoseconds it takes to observe the particle, and how deep it is in space is by calculating how long it is when the particle is observed when it crashes into the particle accelerator wall. It's this same method is how we can predict what particle membrane can be observed in the depths if the space field grid. It's made of layers. Each layer involves a different layer of particles we can observe at that depth. Using light speed as we travel, since light has a limit of velocity, is where we know the depth and the vacuum where that type of particles exist at, correlates how low or high density that depth and space can be measured. It's negative low density or greater high density relative to where and how dense space is at any specific time traveling light speed. At the lowest scale in the SOS fold are the Higgs boson in the Higgs field corridor. Thus is the almost pure vacuum. The less interference where gravity increases the mass of a moving ship. No resistance, no mass increase. At this depth in the space field is where our ship travels. No resistance, not inertial, no infinite mass effects. Time actually doesn't stop as relativity asserts because there's no resistance. As we travel backwards in time to our destination star 5 light years away, it's the space field grid that folds up at light speed or even at speeds greater than light because again there's no resistance, nothing holding us back. We travel at light speed towards our destination star traveling backwards against the grid but with no resistance in the vacuum field, in the Higgs field. As we travel backwards in time to our destination star 5 light years away, it's the space field grid that folds up at light speed or even at speeds greater than light because again there's no resistance, nothing holding us back. We travel at light speed towards our destination star traveling backwards against the grid but with no resistance in the vacuum field, in the Higgs field. Our ship travels forwards in time, meaning forwards against the time it takes to get to our star. Time equals 0, but the time it takes for the physical journey is accounted for. So the journey takes time, but up much less than the average ride. Nor does Earth's time change or the time of our journey to the star, less even time in the ship traveling at light speed. Backwards time meets up with forwards acceleration of our shop and the journey accounting to the clicks is almost 0. Fascinating, isn't it? No journey into the post or the future, just a superluminal ride.